Okay, we're going to start looking at graphing our trig functions. So I'm going to start with how you graph the sine function. So I've got sine of theta. This could just as easily be sine of x if you want to stick to the traditional xy terminology. But so if we keep theta, that just makes this the theta axis instead of the x-axis. It's really no different. It's just a different variable. So in order to get a basic graph, our base function, we're just going to look at values that we know the sign of. So I've got some values up here. We'll start at 0. If you look at your unit circle, the sine of 0 radians, which would be here, okay, I've got a sine value here of 0. So that's a point on my graph. Another point that I know is up here at pi over 2. I know that that's got a sine value of 1. And if I keep going around the circle, here's pi. And at pi, I've got a sine value of 0 again. So this should just be pi, not 2 pi. Okay? And if I go back the other way, so if I go the reverse direction, so if I go back negative pi over 2, that would put me at negative 1. And if I continue around to negative pi, which is what this should be, then I'd be back up at 0 again. So we get this wave graph. Okay, and if you've done waves in science class, then you'll recognize some of the terminology that I'm going to give you to help us graph transformed parts here. Every wave has a wavelength, is what they probably call it in science class. We're going to call it a period. That's the length of one complete wave. There's also an amplitude. That's the height of the wave. And we measure height, not the overall height. So this is not the amplitude. We actually just measure the height from the baseline or from the 0. So it's only here. This is the amplitude. Okay, and our period would be from here to here. Okay, this would be the period. If you notice, our period is from negative pi up to positive pi, which is a total of 2 pi. And our amplitude, since the highest value we can get for sine is 1, that's our amplitude. Another word you're going to have to know is the phase shift. Okay, this is the horizontal shift of the wave. Okay, because phase shifts it's called a phase shift because of science. It shifts it into a different phase of the wave. But for us, we're just going to be using that as terminology so that when we get transformations in our function, we'll say, what's the phase shift? You know, phase shift is left this much or right this much. It's really our c value from our transformation function. Before we start transforming this, let's look at the cosine function, kind of in a similar way. So again, this should be negative pi and just pi. Now cosine at 0, okay, that's my x value, and now that's going to be 1. So I'm going to start up here at 1. Okay, and then at pi over 2, I'm going to be at 0. And at pi, I'm going to be at negative 1. If I go the other way, at negative pi over 2, I'm at 0. And at negative pi, I'm at negative 1. So this is one complete wave. Okay, and it would continue to do this, right? Because we could keep graphing this farther and farther, and it would just, you know, keep going like this because it is a wave. But I just want to show one period. It's still 2 pi. the amplitude is still 1. And in fact, if you look at the sine and the cosine waves, they're almost identical. The only difference is on sine we're starting at 0, and on cosine we're starting at the top of the wave. So really, we could turn the cosine into a sine wave if we just shift it. Okay, if we shift it over pi over 2. Okay, so if I move, or you could think I'm moving the wave pi over 2 to the left, or to the right actually, that would make it a sine wave. So they're very close to each other. They're related very closely. So we talked about amplitude, period, and phase shift. Now, here's how our A, B, C, and D fit in to sine, cosine, tangent, all those different functions. We're going to deal just with sine and cosine today, but this comes again, from our y equals, we've got A, f of B, x minus c plus d. Okay, that same thing we've been dealing with every time we get a new function. So if you remember, usually A is the y movement multiplier. B was the reciprocal. Of the x movement multiplier. C was our, it changes our starting position. Okay, so these change our start point. Okay, C and D are going to do the same thing in here. But now when we look at A and B, we're going to see what they do to our period and our amplitude. Okay, now since A affects the y movement, okay, it affects the up-down motion that we take, we're going to say that instead affects our amplitude. So this multiplies the amplitude. And B, okay, changes the period. So the reciprocal of the period multiplier. Okay, so let's take a look at how these work. So here I've got something with everything in it. The same rule applies. We always want to factor the inside part here. So this is really going to be 2 cosine of 2x minus, now I'm dividing this by 2, so really that's going to become pi over 4 plus 3. So I'm going to be starting up 3 from where I usually do. So I've got a cosine function, which means I usually start here. Okay, now I'm going to be starting up 3. So I'm just going to add some more lines in here. So instead of starting at 1, I'm going to start at 3. And instead of starting at 0, I'm going to start to the right, pi over 4. Okay? Now, from here, my period used to be 2 pi, but now it's going to be 2 pi divided by 2. So it's going to be pi until I get back to here. Okay, so again, I don't know why I kept messing these up, but this should be negative pi and pi. So the whole thing, the whole cosine wave, okay, which looks like this whole thing is usually 2 pi, but now the whole thing is going to be pi. Halfway in between there is where I'm going to find my minimum value. So this is pi over 2 away. And halfway in between these points here is where I'm going to cross my baseline. And here, hold on. So we usually start at 1. If I'm going up 3 from that, I should be at 4. Sorry. So I should be over here. Okay. My baseline, since it's moved, actually, okay. So let's do the same thing that we've done for other aspects. Let's put where our 0, 0 would be in. So our 0, 0 would be over pi over 4 and up 3. This is like my new 0, 0. Okay, now cosine stops at the top of, or starts at the top of the wave. My wave now is too high though. Okay, so it's up 2, my amplitude. So really I need to start up 2 from where my 0, 0 is. Okay, I need to go over pi away from here. So that put me at, so this is pi over 4. If I had another 4 pi over 4, that'd put me at 5 pi over 4, which would be here. And that's where I'll be at the top again. Halfway between those, so pi over 2 away. So if I go pi over 2 away, that'd be 2 pi over 4. So there's 1 pi over 4, 2 pi over 4. That's where I'm going to be at the bottom. And the bottom should be 2 under my baseline here. Okay, so 2 below that. Okay, again, and that 2 comes from this. This is my amplitude now. Halfway between these is where I'll be on my baseline. Same over here. So here's my transformed graph. Okay, and I could continue. I could go pi back this way, which would put me at negative 3 pi over 4. Okay, and that would be the end of another wave. Halfway between these, which would be here, I'd be at the minimum. Halfway between these, I'd be at the baseline again. Same on this side. So I could continue this wave infinitely. Okay, and that's my transformed cosine wave. Let's look at another one here. So my period here has not been, oh, it has been changed. Okay, my period is getting divided by 2 again, so instead of 2 pi, it's going to be pi. My amplitude has not changed, but it's been flipped over. Okay, so it's still 1, but I just have to remember that since it's negative, it'll be going the opposite direction, up, down. Okay, so my start point is not moving up at all, but it is moving to the left, pi, because remember, this is always opposite. So my start point would be here. Okay, this would be my 0, 0, my new 0, 0. On the sine function, we always start at 0, 0. Okay, and then from there, my period is going to be pi. Okay, so remember, sine wave looks like this. Okay, we start at, this is our start point usually. So I usually go over here before I'm back to the same part of the wave cycle. Okay, so I'm going to cross 0 again. So I'm going to go pi away from here, which puts me here. There I'm at 0 again. Halfway between there, I'd be halfway here, which would be in the 0 again. Halfway between these, I'm at the maximum. Maximum being up 1, but now since it's negative, I'm actually going to go down 1. Halfway between these, I'm here. And I could repeat the cycle again. Okay, right now I've got 1 full wavelength. Okay, and I could repeat that. If I go pi over again, I'd be 0. Halfway between, I'd be 0 again. I'd be at the minimum and the maximum. Just like that. And that's the transformed sine function. Okay, so it's not so much about knowing sine values. If you think about the half, 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 everything's a half because waves are split up so nicely. You know, you find your start point, you find your period, you go that far away. Halfway in between there on the sine, you're at 0 again. Halfway between there and your cosine, you're at the minimum because you're starting at the max. Okay, so cosine is actually a little bit more difficult because You don't start at 0, 0, you start at your maximum, which changes depending on what your A value is.